Yes, this is being recorded, so all good, Taye. Oh, okay. I think we can start up. So thank you all for joining us so much. My name is Max Ghenis. I'm the CEO of PolicyEngine. We're a nonprofit that provides an open source software platform for economic policy simulations. And I'm here with my colleagues Ziming Hua and Pavel Makarchuk. Um, and yeah, we're excited to share some of our research and findings and really the software that's come out of our work to automate a major part of our platform development, which is encoding tax and benefit policy rules. So this is a system that, since we started about 5 years ago, we've had to encode hundreds of different policies, tax and benefit policies in the US, UK, Canada, elsewhere at the state, local, and national levels. And depending on the complexity, it's usually taken 2 to 3 weeks because of the manual process of looking through all the documents, encoding the rules in our particular system, doing validation. And Ziming's work has really catapulted the pace of this to be closer to 90 minutes. So we'll show you what that looks like. Just to get started, I'll share a bit about what PolicyEngine is and kick off a live demo, actually. So we're going to usually save demos for last, but today we're going to do it from the beginning so you can see how the process evolves. So we'll actually be able to see a real-time policy encoding by the end of today's session. And we'll move from that to getting back to the slides. And Pavel will talk about our current sort of historical approach
Oh, he's
to
Russian.
um, yes, I think he is. Um, uh, and sort of just more background on like what the scope of the model is, those kind of things. And then Ziming will show you what the evolution, not just what we landed with, but since this is sort of, it was a big learning process for us. So Ziming's going to talk to you about what we learned along the way, all the different stages of developing this system, and where we eventually landed. I think we came away, not all of you, some of you may be doing policy encoding the same way that we are, and we're especially excited to hear your views on our approach. But I think a lot of us are just doing other types of projects that AI can help with. So what we hope to impart is not just our learnings, sort of maybe more confidence in the pace and coverage of our model, but also some general principles that you can use as you're developing your own AI agentic systems to improve your software or your other research or other projects. So, and feel free to jump in with questions along the way, either drop them in the chat or just come off mute. We're not an enormous group, so we can just kind of keep going. Okay. So in general, what is PolicyEngine? We're a software platform that calculates, for example, if you were to expand the child tax credit, how much would that cost? Who wins? Who loses? What's the impact on poverty and inequality? It's an open source platform. We have a Python package and a web interface. And the way we do this is a technique called microsimulation. And this is a technique that's used in the Congressional Budget Office, um, also think tanks like the Urban Institute and academic centers. And there's really three ingredients in these models I'll talk through briefly. So the first one is we want to encode the policies. So we can say, under current law and some other policy reform to the dollar, we're just going to do the math. It's a calculator. How much is in a child tax credit, or potentially if it affects other programs as well, will the policy regime affect a given household? So that's a mechanical deterministic calculation we can do. And that's really the focus of today's presentation. Two, we then assemble a data set of representative households so that we can say not just this is affecting an individual, but society at large. And we have ways of constructing that let you sort of aggregate the impacts. And finally, we incorporate economic theory so that you can say, here's the set of dynamics that might, if someone's marginal tax rate changes, maybe their labor supply is predicted to be affected as well. So we sort of incorporate all three of those. And to make this a little more tangible, we can see an example of how this looks. So here we have a individual who has no kids, $100,000 of income. And what we can do with our model is say, okay, under current law, what is their tax liability? And it's just let's say it's $21,000 under current law. The model is flexible enough so that we can also calculate what their taxes are under some policy reform. So that's $20,000. Um, and economic theory would say, okay, maybe there are tax rate changes that could affect their earnings. So in this case, maybe the structure of it is going to increase their earnings. And then you can recalculate what that means for tax liabilities and revenues. Um, so it's going to be a little less than that $1,000 down to 850. And then we sort of structure it with lots of different households. So we're doing that tens or hundreds of thousands of times. And that's what enables us to estimate the total change in tax, total also number of people affected in different ways, um, and by the policy because we have this micro level approach to it. Um, so, and this is sort of the general approach. Our policy engines sort of angle on each of these. In terms of the policies, we're quite broad. So we do have federal, state income taxes and payroll taxes, as well as the core benefit programs that many of you sort of research or help people navigate: SNAP, Medicaid, ACA subsidies, SSI. And we also have TANF. We'll actually show us the examples Ziming will go through the approach that we've taken for TANF, which has gotten us from just a handful of states because the rules are quite bespoke to the state, down to we only have 2 states left now before we have full nationwide coverage of TANF. And we have some other state level programs as well, like CCDF and state supplements for SSI. Um, in terms of households, we integrate survey and administrative data. And also on the dynamic side, we do enable you as a user to not just take the default elasticities that CPO might have, but you can sort of apply your own behavioral assumptions. In terms of organizations that use PolicyEngine, it includes think tanks around the world, especially the US and the UK, where our models are most developed, as well as academic centers. We're used by the Prime Minister's office in the UK as well as some congressional offices and independent researchers, as well as on the benefit access side, helping organizations like My Friend Ben and Amplify power their eligibility determinations. Okay, so that's sort of the key background. I'm going to switch over to the demo, and we'll come back to this later on, but we'll sort of kick off a few of the pieces here. Let me software sharing. Uh, and uh, it's going to be this one. Okay. Now, this, if you haven't seen a terminal before, this is Claude Code. And this is, well, this isn't Claude Code yet, actually. This is just a terminal, which is
I
sort
think
of a way
you're still
oh,
sharing the demo.
oh, thank you.
Yep.
Uh, now? Okay, thank you. Um, So yeah, this is a program called VS Code, but it's just a way for developers to create software. You really don't even need this kind of software anymore. You can just use the Claude app. But you may have used services like ChatGPT, Claude, or Gemini as the chat interfaces. And what we're showing you today is a next level version of this, which really kicked off about a year ago when Anthropic released Claude Code. And this is a program that works on your local computer. So I can just type Claude here. And now it's going to give you access to those kind of AI systems, but it's going to run on your machine in a more agentic way. So it's going to be able to say, we have some task ahead of us. I'm not just going to do one command. I'm going to keep doing lots of commands or validate what we're building in a way that can provide the ultimate answer. So you can have much more complex tasks that you give it. It can build projects file by file. It can access lots of files and other services, including PolicyEngine. So we're both going to start by just seeing what Claude Code can do. And if you're using other tools like Codex for OpenAI or Gemini CLI, it's not going to be that different. Um, but we can both use it to access Policy Engine software and to improve it. So for example, let's say we are interested in a benefit eligibility determination. So we might want to know for a single parent in LA County, what is the maximum TANF benefit? And I'll say single parent of two. Okay. So now there's a few ways it could go about this. It might try to look up the documentation online. Because we have Policy Engine installed and we actually have a plugin that enables you to access a wide range of what's called skills, subagents, things that we've cultivated to make both developing and accessing Policy Engine software easier. So it's now using that skill, sort of loading it into memory. It now knows how to run the Policy Engine software here. So that's what it's doing. It's just writing some Python code, and it's going to spit out what the value of this maximum benefit is. This should be done in just a moment. And you can kind of see it's maybe looking through a few of the different pieces, some of the ingredients that it needs to pass to our software to get the accurate answer. So for example, I actually didn't give it all the information it needs. In California, the TANF program, Temporary Assistance for Needy Families, has has a couple dimensions. It's both based on geography within the state and also whether they are exempt from work requirements. So it might give me a couple of answers here. Yep, there we can see exempt, non-exempt. And we have thousands of programs like this in the system. I just sort of picked this randomly. So, and there it is. So it looks like it's going to give us two numbers. Um, there we go, 1314 per month or 1175 per month if they're non-exempt. Okay. So that's cool, but really the heart of what we do is calculate what people are actually eligible for. So I'm just going to, and it's sort of giving some helper stuff here. I'm going to ask how much would they be eligible for if they earn 1K a month. Now this will take a little bit longer, so I'm just going to come back to this and in a separate tab, I'm going to kick off what really the thrust of today's talk is about, which is we are going to expand Policy Engine software base together. So one of the nice things about the Claude Code ecosystem is you can create these sort of custom commands. So one of these is encode policy that we've developed in our plugin. And for this policy, I'm just going to pick a random state. We have not encoded this state before. So I'm going to say New Mexico SSI state supplement. We haven't even tested with the state. So we're really doing a full live demo here. And now Ziming will talk through each of the stages here, but this is a full sort of spectrum from the first step is phase one. So there's some stuff specific to TANF, which it's skipping. But stage one is it's going to file an issue on GitHub. So it's just going to collect some of the information it needs to make a well-formed sort of task that we can document. It's doing some stuff around Git. If you've used Git or GitHub before, some of these commands might look familiar to you, but really the age of needing to know that stuff is kind of behind us because these tools can all do it automatically. So it's looking for the open issues, and we'll just go through like the first stage or two of this. It's confirming that there's no code around it. There's no existing PRs either, pull requests, sorry, sort of changes that have been proposed to enact it. And once it gets a little bit further, it's going to start collecting the documents and actually launching new agents to execute the implementation of this policy. While we get just a little further than that, let's check in on our amount. Okay, so it now ran PolicyEngine, and if you've used or are you familiar with tools like My Friend Ben and Amplify, this is exactly the kind of calculation that we offer on the back end there. So it's running through the numbers and it's calculating that they're eligible for 975 per month. Um, and here, okay, great. So now back to our automatic section. It's sort of setting up a task list for itself, creating the issue, and you'll sort of see it's doing once it's done with that, it'll start collecting the documents, implementing the policy, and doing some validation before it finally completes the implementation. Before I go back to the slides, I'm curious if, yeah, any questions on this approach, if folks have used tools like Claude Code before, um, or if this is totally sort of foreign so far. Okay. Well, I'm just going to try one more thing, and we'll come back to this as well. This will take a little longer, but I'm actually going to an event tomorrow on benefit cliffs. So we're going to see if it can also calculate how big is the cliff. So the cliff is, at a certain point, if you earn a dollar more, you're going to lose more than a dollar in benefits. There's some sort of minimum benefit before you lose eligibility. So it's going to go through not just one calculation, but lots of calculations to answer this question. And then, so we'll later in the session, we'll come back both to all these phases and hopefully get a working implementation and also an answer to this cliff size question. So with that, I will pass it on. Oh, there were some, uh, sorry, I missed the questions in the chat. Um, how are we collecting the documents? We will get into that, Margaret. And do we provide? No, we don't. Yeah. Part of it is, and we'll actually get to see this here, it's looking through all the issues in our system. It's also looking through our code base. So it has a sense of the kind of documents that we've cited in the past. But it will use that and also do a bunch of Google or web searches to actually find the documents themselves. Um, Great question, Maximilian. I'm going to save that for the end just because it's a little bit separate from the core the encodings. But yeah, we've done a lot of work into making sure that our imputations are calibrated for the microsimulation part. So eager to discuss that. Okay, with that, I'll pass it to Pavel to talk about how this process has looked prior to this.
Awesome. Great. So I will go through our manual process that when I joined PolicyEngine about 2, 3 years ago was kind of 80, 90% of my day-to-day work. I'll give some background on how our code is structured in our public GitHub repositories. You can also access all of those on Git, all the production code. You can also see the pull requests as they're being developed, and then kind of talk a bit about coverage and also the problem of scope that arises from our approach we're taking to encoding these policies. So when we want to add a new program, when we want to make either an addition to something that's already existing, add something from scratch, there are around 7 phases that we go through, which Ziming will expand on as well, that we try to mimic. But to break it down, we collect the documents manually. So we'll go do web searches, look at previous references, legal code, statutes, policy manuals, tax forms if they're available, and break those out into, again, 3 ingredients. Those are the parameters, the variables, and the tests. In the parameters, we store all of the numeric values such as maximum benefit amounts, income thresholds, age thresholds, also lists of different types of income that, for example, go into like the earned income bucket of a specific parameter, specific program. And we store those as YAML files. And they not only have the values that can be then accessed through the Python code, but also have some metadata. This is where we store all the references that we use. We only cite primary sources for those parameters to make sure we align with legal code as closely as we can. It also has the description, so people, if they want to use it or for front-end purposes, we can access that. And then metadata such as the units, so if it's in dollars or if it's a percentage, the definition period, so this is a monthly amount versus a yearly amount, some more specific things for different parameters. Then we go to the variable code, and this is where all of the actual Python code is housed. We translate the legal code line by line into this Python structure. So it's a mathematical representation of the legal code structure. It has access to the parameters, so all of the numeric values, dollar values, etc., are all embedded within the Python code. It also has some metadata around it, such as labeling, documentation, the period, as well as the reference that we use to construct the specific variable, um, and then what it actually represents in the whole ecosystem. And then we have tests. So we write unit tests. So each individual formula is tested from different angles, edge cases, counterfactuals, to see that it actually behaves the way we expect. And we also write integration tests. So given a set node inputs such as employment income and age for a household, what is the actual benefit amount without giving it any of the intermediate calculations to test it end to end and not just in isolation for the individual values. And we've applied this to numerous programs throughout our system. We have about 65 total programs. We have complete coverage of the federal and state income taxes. We have benefit programs across all states, such as TANF, WIC, school meals. Currently working in TANF, as Max has said, very excited to get this over the finish line. And then some state and local programs as well, partially in collaboration with our benefit access partners, as California specific programs, and for other states as well as very localized programs such as the Easy Safe in Los Angeles County, some programs in Riverside County, other states. And this tool is also publicly available, so you can see our whole coverage. You can also go through the details and look at actual code in our GitHub repository for each of these programs. So looking at this scale paired with the manual process, we, over the last years, ran into the challenge of scale. So the whole process of researching the official sources, writing the YAML parameters, variable logic, testing it, doing multiple rounds of validation, as well as review rounds, has taken us to a process that takes about 2 to 3 weeks for a standard benefit program, sometimes a little longer if there are more complex rules, sometimes a little faster if there's less, but that amounts to about 1,500 lines of code per program. And if you look at it, 50 plus states with individual programs, local area programs, it really forces us to think about how can we do this more sustainably. There's a number of repeated processes. We have very clear code guidelines and styling guidelines. We worked with a number of volunteer contributors previously on this process, but over the last month, the reason why we're here is we landed on the solution of this multi-agent AI workflow. Just to give a little bit of context to some of the terminology that Ziming will use throughout his part of the presentation, we'll talk a lot about agents, which you can think of as autonomous AI workers that can read files, run code, run tests, and also then make decisions based on the characteristics that they're given. So they each have a markdown file that has a very clear set of rules that are implemented. So anything from code styling to testing purposes, and they can be separated and individualized. We're also going to talk about skills, which you can think of as reusable prompts that can tell an agent of how to do specific tasks, especially if there's repeated code styling assignments, repeated things that scale across the entire code base. It's like a detailed checklist that you can give to a developer, almost like a policy manual that they can read and iterate through that doesn't have to be shared around. And then we'll also talk about plugins, which are bundles of agents and skills that can be shared across projects, like installing an extension and giving access. That's what is just demoed. Before I turn it over to Ziming to talk about the iteration flow that we went through to get to the orchestration, I forgot any kind of high-level questions on our manual process, anything specific to the code base. Happy. Take a second. I can't really see the chat, so if there's any question, let's take it.
Hey, Pavel, it's Andy. Hello
Andy.
again. My question will be more interesting next, but how do you maintain the code as laws and regs change?
Yes.
I think the answer is going to come in the next section.
Yes, we'll talk about that after we talk the process. That's definitely kind of the tail ends of just encoding a policy that we looked at. We had somewhat shared projects where we looked into a compository of references as well that we can look through and see if they're like a hyperlink change, there's a new update, like tracking any bills that are being. But Max will get to that towards the end of it. Awesome.
Pedro,
Yes.
go
Hello.
ahead.
Hello. Yeah. What method are you using for this law-to-code translation, and what's the profile of the team that applies this method?
The team is our PolicyEngine team. So we have a different number of backgrounds that we have on the team, anything from economics backgrounds with some coding skills to CS backgrounds that then got into the policy space. So it's kind of a range of both sides of the spectrum that we operate in. And we try to make these workflows and agents usable by the entire team of PolicyEngine. So anybody who either writes or encodes policy or actually like writes it, etc. And then I missed the first part of your question, sorry.
The method. What's
Oh, the
the
method.
method used throughout all the translations from law-to-code?
We translated into Python code. I'm not sure if I follow the question, Max, if you
Well,
have.
we're about to show you some of the
Okay,
step by
sweet.
step, like how the AI fills in. I don't know, Pavel, if you can go back to the part with the variables, parameters, and tests. So the mission of us as humans for the past 5 years and now the AIs is to turn a policy document or a series of policy documents into these basically sets of parameter files, variables, and tests. So that's what we'll show sort of the sequence of. And Ekaterina asked how you handle changes in the documents or programs after they've already been processed. I think this is very similar to Andy's question, which we'll get to toward the end. So,
Awesome, Ziming, if you want to take it away.
Oh, thanks. Yeah, so like the vision for this AI system is that we only need to input the name of the program and it should return a draft pull request with all the files that we need. So that's how I got started. The first prompt has only 2 words, Texas TANF. And the output was horrible, like wrong formatting everywhere, hard-coded values in the formulas, no citation to the legal code or any source documentations, tests that passed but the formula were wrong. So because the model didn't understand the way of our, modeling a program in PolicyEngine. So even if I add more detail to the prompt, such as the program requirements, coding conventions, file structure rules, testing standards, the result was still bad. Like error rate goes up to like 70%. And the more context in the prompt didn't fix the problem. The model couldn't hold the coding standard, the citation, and all the testing pattern all at once. It always missed something. And as for the example, you can see, like it's gonna put all parameter into one YAML file, and there's no metadata or any reference for it. And for the variable, it doesn't match our standard, and it's hard coding in the value, and it's missing the entity definition period. And for test, there's no test. So the first attempt was bad. And the key takeaway we take from this attempt is that one single prompt cannot reliably handle a complex model. So that's why we have the next evolution step, which is a core pipeline. If one prompt cannot handle everything, we divide the work. So that's where we use these agents. They are specialized AI workers that each focus on a single aspect. We have 4 agents running sequentially. Document collector, which gathers information. Parameter architect, which turns legal values into structural YAML files. A rules engineer, which implements the logic, the computation. And a test creator, written integration tests. The result was better. Each agent had a shorter focus prompt, easier to debug which step failed, and we could improve agent independently. But this pipeline has a blind spot. The test creator ran after the rules engineer, and it could see the implementation. So it wrote tests that validate what was built, not what the regulation actually required. If the rules engineer had a bug, the task creator would just follow the path. As you can see the example, let me see what's wrong. We can look at the parameter first. I mean, it has a better structure, but for example, it only has one unit size for that year. And for the parameter, it's didn't like in this case, the definition period is wrong. Like the parameter represents a monthly value, but now it's a yearly variable, which doesn't align. And the test case did not catch it because it's follow what was built by the rules engineer. And the key takeaway from this is that sequential pipeline create a confirmation bias. Tests should design to verify the actual law, not validate the implementations. So in order to make sure tests are honest, representing the actual law, we using this evolution, parallel execution. This is a key insight that changed our architecture. We run a test creator and rules engineer in parallel. So both read the same documentation from the document collector. Neither sees other's output. In this case, when the test fails, it means there's an actual disparity between what the regulation says and what the code does. We also add a implement validator to check the result. So error rate dropped from 70% to 40%. Still not great, but it's an improvement. So we are catching the real bugs now. If you look at the example, let me see. Yeah, the parameter gets better. Still some work on the, let's say, label or description, and the parameter and the variable. Let me see. Yeah, I think in this case we should look at the test first. So this is just an example. So suppose the eligibility requirement need to check both income and resources, but now in the variable we only check the income, and the test can catch that we are missing the resources eligibility test. And the key takeaway from this is that agent isolation prevents confirmation bias. And when agents cannot see each other's work, mismatch reveal the actual problems. So we go to the next step. With the success we had from the last evolution, we added 3 more specialized agents. Edge case generator, which creates boundary test, things like what happened at 0 income or at exact threshold, or a family with 10 children. A reference validator checks that every parameter actually cites the real legal document with subsection names. And CI fixer that would run tests in local and fix whatever goes wrong. The CI fixer was important. Like before this iteration, when the test failed, a human like me, I need to look at the error and figure out what's wrong and fix them, and then rerun tests. Go through this process over and over. But now this workflow becomes a loop. Like CI fixer, it will analyze the test failure, fix the code, and retry until everything passes. This got us much further, but we hit a different problem: inconsistency. We now have 8 agents, and each one has its own prompt, which is its own copy of rules, and the same instruction kind of overlap in all agents. So when we update a rule, like we have to update it in all 8 places. It's not a sustainable workflow. If you look at the example,
can you just explain what CI is as well?
It runs tests to check if your test file pass. It's a GitHub feature, I would say.
Yeah, so this continuous integration step is what every time we make a change to the model, it's running a slew of thousands of tests automatically that we have to pass before we're able to insert that new code. So what this CI fixer agent is doing then is making sure that it aligns with any of the feedback that the continuous integration process is getting. Is that right, Ziming?
Yeah.
Great, thanks.
Yeah, so the key takeaway we take from this evolution is that more agents means more capabilities, but also more surface areas for inconsistency. Like repeated instruction are maintenance problem. So this is where we decided to use skills. Next step. Yeah, so skills is a new feature that Claude Code added in late October. They are reusable knowledge modules that agents can load on demand. Instead of every agent carrying its own copy of how to write parameter, how to write test, we extract that knowledge into a focused document. Uh, yeah, basically if you it's interactive, right? Oh, yeah. So basically, the variable skills is used by the rules engineer and document collector, even the parameter architect, and the same goes on. So with this skill is a life changer. The error rate dropped to 15%, and more importantly, adding new agents become easy. Just point them at the right skills. And for the example we had, I think yeah, now it's handle the uh parameter or the formatting and variable has improved a lot. Like they are mostly correct. Maybe some minor issue I would add, but yeah, it pretty much covers everything at this step when the skill is added. So basically the takeaway is like skills let you scale without redundancy. One skill, many agents, like consistent patterns everywhere. And the last evolution we add this orchestration. So an issue manager finds or create issue, like the demo issue you seen earlier. And a PR pusher will create the pull request. And we also add a program reviewer, which validates the implement against the regulation one more time, and then updating the PR description. So it's easier for human review. And one command, it will trigger the entire workflow. So about 90 minutes later, you will have a draft pull request with parameters, variables, tests, and documentations. And human review makes the merge decisions. As for the example, I think I just showing the folder structure of each parameter, test, and variables. So that's how like New Hampshire TANF looks like in our repository. Yeah, so here's some design principle I learned throughout these evolution steps. I wish I know them earlier, which definitely could save me a lot of times, but failure experience is the key to success as well. So 5 design principle. The first one is about source authority, which we only collect primary sources, anchor the parameters to statuses, regulations, state plan, and let's say policy manuals, and only use forms and benefit calculators as a supporting reference, not the primary ones. And also like isolation, like certain agents must not see each other's output. That's like the evolution we have in evolution 3. Like this is how we prevent confirmation bias. And then share knowledge, which is the skills. Like build your skills that suits your organization's need. And they are reusable to many agents. And orchestration Python, which like the orchestrator coordinates without implemented. It invokes specialized agent to complete this full workflow and manage the workflow. And lastly, composability. Agent are skills, they are all like building blocks. You can rearrange them into different workflows. The same validator agent works in all like encode policy command. We have a command called review pull request, also a command called fix pull request, which is being used by it use the same agents over and over again. Like you build a library of capabilities, then you compose them as you need.
Thank you, Ziming. Yeah. So as you've seen, the results and the impact it's had on our ability to encode policies that both improve evidence-based policymaking and help people understand what they're eligible for has been quite staggering. So the pace that we've been able to add new programs has gone from 2 to 3 weeks to about 90 minutes for a program like TANF. And it's resulted in us adding 45 more states to TANF. Essentially, we have nationwide parity. We'll probably finish that tomorrow. In terms of lines of code, not always something to be proud of, but in this case, the policies are kind of just complicated. So the lines of code over 60,000 really does represent the level of legal complexity that comes from statutes, regulations, program manuals, lots of different documents that have different features of the policy that we've been able to automate. So we're still at the stage where humans are reviewing the final result. We hope to automate that, have enough confidence in it over time that we can sort of just go from zero to implementation, at least for programs of a certain category. But for now, we're still learning, still iterating to get that last 10% or so of the program done. And it's had, an impact in a recent launch. So my friend Ben is a benefit access tool, a multi-benefit navigator that recently launched in Illinois. And this setup enabled them to do that more rapidly as it expedited our encoding of their Illinois programs. So with that, if you want everything we've shown you or that I guess I've shown you, and also, the flavors of what Ziming shared, everything we do is open source and publicly available. So if you want to contribute to the code base, as we are doing with Claude Code, you can use these commands to do that. You can also do all the commands I shared earlier to get insights about the impact of public policies. So with that, I'm going to just wrap it up and show what we landed on. So we'll see how Ziming's system actually resulted in encodings. And it's perfect timing because it just finished like 2 minutes ago. I was watching it, and we can sort of see from the top. Well, we might not be able to see the whole top. Oh, yeah, okay. Let's see. I think we were about here when it stopped. So we've got this phase one, the issue creator that Ziming was speaking about. The document collector, it was phase two. So I think this question came up earlier about where the documents come from. So it was starting to pull. It's very proud of itself that it could find all the documents. Excellent. So yeah, and we can ask it what those documents are. We'll see it in the code as well. Now it's actually doing, sometimes if you have too many of these open, which I have another window of, some of the text gets a little corrupted. But it's actually now pulling in the encodings. There's first the parameters and the variables and the tests. But critically, it's got the separate agent for the tests. So those are all happening in parallel, the edge case tests and also the main tests. Ziming, please correct me if I'm getting any of this wrong as we're going. And now, yeah, it's finally sort of doing more of it. Here are the paths where it's putting in the new code. And yeah, it shows that it's complete. I'll actually drop this in the chat. So if any of you want to take a look, you can do that. And yeah, it sort of summarizes what it did. So we've got various integration tests. Ziming, could you answer Andy's question about where the test cases come from? How are they different in
Yeah,
different
sure. Test cases come from the document collectors. Like after document collector, gather all the information, it will write a file called working_reference.md, which you can see in the pull request or anywhere. So the test creator will design test cases based on their references. Where that references is a summary of the legal code or any regulations or policy manuals.
So it'll do that for each run. It'll create new test cases.
If the test case fail, it will check what's going on. Is it usually the test cases represent a real life, and if it says something failed, it means maybe the implementation is wrong, like the variable is wrong, and it will instruct the rules engineer to take a look what's going on.
I mean, maybe I'll just speak in English because I'm not a technician. I want to use this product to give millions of people information so that they make more claims in their states. And I'm worried that the states will say, you can't trust the accuracy of this thing because it's not using test cases that we've verified. How do you respond to that argument?
Well, the states don't usually provide public test cases. When they do, we definitely ingest them.
Sure.
Also, tools like my friend Ben in Illinois, they I think work with the agencies and come up with their own test cases, which we also ingest. So we're very glad to take any of these validation opportunities wherever they
Right.
arise.
But because they don't, you have to create your own
That's
to
right.
do the best you can. And so there's a potential perceived or real accuracy gap that you know is on my mind, right? I mean,
Yep.
it doesn't discount that this is awesome, and I can see a path to thousands of programs being added to my friend Ben more quickly. But it just accelerates this concern I have, becoming a concern.
Yeah, so Ziming can speak to the prompts that went into. I think you've done quite a bit of refining of the prompts for constructing the tests. In terms of like, for example, we want to capture the edge cases where they're barely eligible, barely not, across lots of different dimensions, but also more typical kind of cases.
Yeah,
Um, I mean, let's see what it did here. So it looks like 18 total test cases for this program. Um, Figuring out first like all the combinations of eligibility based on
yeah, yeah,
um, and then some numerical ones as well. And I mean, these integration ones are these historically when we did by hand were some of the most time intensive to do because we would basically sit down with the whole document, not encode anything, and just try to fill out the form ourselves.
yeah. No.
So it did seven of those as well. What do you think? How's this?
So I think the situation hasn't changed from what it was before, right? You have to construct test cases as best you can from the text in the regs.
Yeah, we don't have
And
like
now you can just do it faster. And in each run, it's going to create the same or similar test because it's reading the same regs, unless the regs changed.
That's right. Yeah, we would love to partner with agencies that have administrative data that we can build test cases off of. That is, we don't have
No,
that kind of
understood, understood.
yeah,
We're all trying to estimate and predict better,
yeah.
without having the gold cases to measure accuracy to.
There's a lot more we could do on this front, and yeah, would love to brainstorm with you, Andy, on how we could do it better.
Yeah, again, I just see a path to having that problem is now
Yeah,
coming even faster thanks to what you guys have just demonstrated.
yeah. I guess this sort of ties to one of the earlier questions as well. From Margaret about the distinction around primary sources. So, for example, the statutes versus regulations versus the forms and benefit manuals. Pavel or Ziming, could you talk about that?
Yeah, we went through a number of iterations to get to the set that we finally landed on, building off like the example of some of the legacy code that we had, but we classify different sources in the description as well. As we're going through the iteration cycles, like we know that like the website of the actual legal statutes is a trusted source. We trust certain state government websites as well. So if it sees that it is an official government source, we trust it. And as we go through the iteration cycles that Ziming has shown, and we see that it does apply a reference that we don't have full confidence in, we quote unquote blacklist it and similar references in the prompt, and then rerun it until it gets it right. So it's like an iterative process to get to the set that we have now.
But usually to encode the policy in full, you have to consult all of these types of policy documents. Maybe the statutes define what the eligibility criteria were when the program was created in 2012 or something like that. And then the regulations might fill in some of the gaps, but the annual updates are happening through the agency, which is just publishing it via a policy manual. So all of those we would consider policy documents as long as they're like, if the manual is just restating what's in the statute directly because there's been no inflation adjustments, then we might not cite that, or we'll cite it, but only to show that it reflects the statute. What we don't do is, for example, unless we really have to and the government hasn't published something, we won't like go to some nonprofit's website to try to say, okay, they think that the maximum benefit is X. We'll really do as much digging as we can, and that we instruct the AI now to do this to find a government source.
And that feeds a little bit into kind of store documents and how the changes affect the policy. We also store as part of the document collection the effective date of the source. So certain documents are published annually, things like policy manuals. So we also get each iteration of these documents and then filter out by effective date to get the newest version. And then we'll talk about the next steps just in the next slide, but want to also think about how we can then do historic document implementation. We do handle it in the code. I know there was a question earlier, like we backdate our parameters with an effective date tag. So if there's a change due to inflation, depending on what year run our simulation over, you get the values for the actual effective date. And same goes for logic. We have either like parallel structures if the logic completely changes and a state like rewrites the way they do the child tax credit and maybe decouple from like the federal rules, or has like a match. If there's a year-to-year change, we account for all of those as well, tied to the definition period in the year, which is then passed through in the simulation and microsimulation.
Yeah, so in this case, for example, there were quite a bit of New Mexico statutes that it did cite, but it also had to consult, well, SSA, US code for some pieces. Sometimes like the state statute will refer to a federal statute, so it'll go off that. And then it looks like there's also some confirmation of the benefit amounts. I probably sort of look into that. Yeah, there were no policy manuals or forms, so it had to fill in everything from statute. Real quick, so I can stop showing you guys fixed width font stuff. This is the other question that we asked the other session around, again, what is, for a single parent of two in LA County, we started with what's the maximum benefit, then asked it to calculate an amount, and now calculated the size of the cliff. So they lose eligibility at 2205 in earnings, and that results in a cliff of 374 per month, which is about 4485. So this is the kind of thing we hope to add into our web interface as well, so you don't have to use Claude Code yourself. But increasingly, we do see these kind of AI interfaces as the way that we expect many users to get information. So we're trying to just provide the computational infrastructure to make that more accurate. So I think we just have one. Let's see. Actually, we've got another couple questions. Where the remaining errors are coming from. Ziming, could you talk about that?
Yeah, sure. It's the way we wrote variables. Like let's say a TANF program income test. Depending if you are, new applicant or existing recipient, you might have 2 or 3 income tests with income deduction or without. And many times in the current workflow, it will, put all income tests into one variable file. But I would like split them up so it's easier for our future analysis purposes. But in terms of the logic, it's correct. It's just I think there's a better way to present them. So, and also I think there's a and regarding the Pedro's question, like what happened, how would it handle contradiction between regulations? Sometimes these things happen, like there's a contradiction between the regulation and let's say with the policy manual. The current approach is it will use the policy manual. That's kind of my personal approach. Also, I designed it, so that's my personal approach. I prefer the policy manual or state plan, because they update annually or they update more frequently. And also, if there's a contradict, it will leave like a note in the PR description so that you have verified on your own.
And this kind of applies also on like the state tax side. When I would do a lot of like the state tax modeling back in the day, there's sometimes ambiguities in the legal code that could be interpreted one way or another. That's when we refer to state tax forms, for example, that show exactly what people would fill in, because that gives us some confidence that this is the calculation that is intended and will be then executed at the back end if there's ambiguities.
Yeah, so I think this final slide touches on a couple of the last questions as well in terms of what's next. So we've done this now for 45 different TANF programs. That's how this is all evolved. And we're starting to do with some other programs like SSI state supplements and also childcare subsidies. Also looking at, for example, LIHEAP. So all these programs that sort of have more state level variation that we haven't put in the program yet. Um, there are still more things we can do with it. For example, of course, keep policies up to date. I mean, right now we're in the midst of updating all of the state level tax. States are releasing their tax forms, so we can use those to update our model there. It's not quite the same flow as what we've shown for going from zero to the full program, but we can use and reuse some of the, for example, the skills and the agents to do that. So, Katie, to your question, definitely we're not using leveraging AI to detect changes. Actually, that's not true, right? Because Pavel, you're looking at some of the legislation and parsing that with AI.
Yes. To give a quick 30-minute breakdown of what I was
Yeah.
trying to do, given the inspiration I had from Ziming's work, is currently a lot of states are going through state legislative session. So we wanted to have a way to take a look at all the bills are going through the representative houses and all the changes that are being proposed, being able to do some analysis on these bills that are relevant to our model. So we've orchestrated a similar structure where we collect from Legiscan to provide an API where you can get all of the bills that have been introduced. And then there's a very similar circular flow of reading through the document, extracting the changes, looking at our code and seeing if this change would affect our model or not affect it. And then it'll further go through or track the bill every day at every iteration to see if there have been changes to the bill, if it like passed further within the process of being signed, and if it's actually then signed and applied into law. So that's kind of our first attempt at monitoring the legal landscape and what's being proposed, what's being discussed, and then have a way to also get notifications about bills being signed into law and then applied to the model.
But usually we sort of know when, every year the taxes update. Every October is when a range of benefit programs update. So this is sort of giving us more of a heads up. Maximilian asked about waiting periods, time limits, and work history. We do have that for some programs, although the typical nature of how programs access our rules is just point in time. So that's why it's not quite as developed as the other pieces. So if we have to look at how long have you participated in TANF, for example, that is possible in our system. It's just not currently used in that like longitudinal way by our customers. But it's definitely possible in our system, and we're looking more at it. And yeah, other than that, we're doing just eager to hear, the space is evolving, a new model launched last week. So every kind of time we think we've reached the most we can do, we continue to look at bigger, just how we can set our sites bigger to more history, more programs, more accuracy, more details of the program. So we look forward to sharing that with you more as we continue this journey. Feel free to reach out if you have any other comments or questions. And thank you so much for tuning in.